Hey, today we're going to be doing Desmos Unit 5, Lesson 7, or if you're online, it's Practice 7.5.7. Let's get started. So we got the warm-up. It says decide whether each expression is negative, positive, or zero. So what we're practicing right now is just knowing the rules of when you're multiplying and dividing positive and negative numbers, do those answers come out positive or negative? Um, the first thing you do is you just multiply the numbers regularly, like 2 times 6. Sorry, 2 times 6. 2 times 3 is 6. All right, and then just look at um, like the positives and negatives that you had in your problem and determine whether the answer, which we call the product here, is positive or negative. So here's what I'm going to do. I'm going to look down the line here. I notice I got a 2 and a 3 here. Yeah, one of them's negative, but it's a 2 and a 3. Okay, so the answer is going to be either positive or negative 6. So I'm just going to throw a 6 there. I got a 2 and a 3 again. Of course, we got some negatives to think about, but I know the answer is going to be positive or negative 6. And again, a 1 times a 2 times a 3 is going to be a 6. All right, now let's just think about our rules and determine which ones of these need to be positive and which ones should be negative. There's this thing that I might have shown you in class by now. I might not have, depending on what's going on in class. But some students find this thing kind of useful. You draw this triangle, right? Put a negative symbol down here at the two bottom vertices of the triangle and a positive symbol up here. And now when you're multiplying two numbers, what you do is you take your fingers, your thumbs, whatever, and you cover up the two symbols of whatever the two numbers in the problem are. And the symbol that you can still see, that's what your answer is. Now, I kind of don't feel like we need this for the first one. In fact, there's really no way to use this for the first one. It's a positive times a positive. Of course, the answer is positive. You've been doing this since first grade or whatever. But let's think about the second one. Negative times a positive. We got negative times a positive. The answer is going to be negative. And if you want to see it on this thing, what you do is take two fingers, cover a negative symbol, cover a positive symbol, and see how the only one we can still see now is a negative? That's a reminder for us. The answer is negative. All right, here we got a negative times a negative. Let's use our triangle. Cover the two negative symbols. That's a reminder that the answer is positive. I don't have to write a positive symbol on there. I just leave it blank. And then here, it's kind of hard to use this this triangle for things that are more than two numbers being multiplied. You can, there's a way to do it. If you want to figure it out, go ahead. But when you got more than two, there's another trick you can think about. Hopefully you're starting to remember that if you have a negative times a negative, that's going to make a positive. So if you wind up with two negative symbols, that makes a positive. So if we had four negative symbols, you'd have 2 and you'd have 2. Both of those would make positives and the whole thing would turn out positive. If you had 6 negative symbols, you'd have 2, 2, and 2 negative symbols. Each pair of 2 would create a positive and the whole thing would wind up being positive. But if you have an odd number, like let's say 3, like we have here, these two right here, these two negative symbols could combine to make a positive. But then when you've got this third negative symbol, it sort of throws everything off because now you've got positive times a negative and you wind up with a negative. So here's the rule, and this is a good one to remember, memorize this. If you've got an even number, this symbol right here means number, of negative symbols, then the answer will be positive, okay? Let me read what this means again. I don't know why I wrote off. That should be of. Even number of negative symbols equals positive. Odd number of negative symbols equals negative. Good trick, good rule to remember. All right, let's move on. It says determine the value of each expression. So it looks like it's just more of the same, right? We're just checking our multiplying by positive and negative. So we got a 5 times a 3, that's 15. And then we got 1 positive times 1 negative. Use this if you need help. What's a positive times a negative? It's a negative. Okay, next, we got negative 5 times 3. Again, it's 5 times 3, that's 15. And then it doesn't matter that they switch the numbers. This time the 5 is negative and 3 is positive. It's still One negative, one positive. So we got a negative answer. My dog's over here eating her food. I don't know if you can hear that in the video, like this little noise in the background. It's Panda Bear eating her dog food. Okay, next we got a negative times a negative. So it's still 5 times 3, it's 15. But if you got a negative and a negative, they're going to make a positive. So we're going to leave that positive this time. And again, you got positive here. Negative times negative is positive. I will leave you to figure out what 5 times 0.3 is, though. All right, moving on. It says a bug is crawling down a tree at a rate of -7 millimeters per second. Okay, so the bug's going down. This is supposed to be like the Desmos you did in class either today or the other day or whatever with the turtles, where if the turtle was walking to the left on the little racetrack, then we consider that like negative movement, sort of like negative on a number line. And if the turtle is moving to the right on the racetrack, then we consider that positive movement. So this bug is on a tree, and we're going to think of downward movement on the tree as negative and upward movement on the tree as positive. And then there's this element of time, right? The Desmos activity I'm referring to, I think is called like Turtles in Time or Back in Time or something like that. And you could rewind the races, right? And if the turtles are like going back in time, like they're walking backwards, then that's like negative time. And if they're walking forward, like you're pressing play or whatever, then that's positive time. So same thing here. If the bug is moving forward, which for him is down the tree, then that's going to be positive time. And if we rewind him, so he like walks backwards up the tree, then we're going to think of that as negative time. All right, so he's walking down the tree at -7 millimeters per second. He passes a big branch, which we're going to call 0. Which equation represents the bug's position 8 seconds after it passes the branch? So forward in time, positive time, if we're talking about after. So we want the -7 rate times 8 positive seconds. So this one looks right off top, but I don't agree with the answer being positive 56. Positive 56 would mean the bug is somehow 56 feet up the tree, right? But he's moving down and time is going forward. So he should be down at -56. It's gonna be this one. Okay, now this next one says, what about 8 seconds before he passes the branch? Now I'm not going to give you the answer on this one. I'll help you though. So you need a -7 to represent the fact that he's going -7. His rate is -7. But this time, since it's before he passes the branch, we need to like rewind him. We need that -8 seconds of time. So you're looking for one that says -7 times -8 and then has the right answer for that. Will that bug be at positive 56 way up the tree, or will that bug be at -56 down the tree? Okay, you figure that one out. All right, and then lastly, describe a situation that could be represented by the equation 7 times -8 equals 56, -56. Okay, well, maybe this is a different bug, because this bug is walking up the tree, right? This bug has a rate of +7. So there's another bug going up the tree at 7 millimeters per second. I'm just going to write MPS. That's actually, I guess millimeters should be mm, because M is just miles. So maybe MPS. Okay. And then -8, that would be before he passes that branch on the tree. There's this branch on the tree that we're considering 0 or whatever, according to the original question. So if we have -8 seconds of time, then we want to know, where is this bug 8 seconds before he passes? And then describe what the -56 means there. Okay, so this is like half of an answer, and I want you to finish it from there. All right, a bug has friends on nearby trees. Write equations similar to problem 2. For each description, assume each bug starts at the same position as the bug in problem 2. So, and the bug at problem 2 is like crossing that branch on the tree that we're thinking about is 0. So Buggo crawls for 28 minutes at a rate of, now Panda Bear's going for a water. 28 minutes at a rate of -2 centimeters per minute. Okay, so 28 minutes of time times a rate of -2. Hey, you need an answer for that. Where's that bug going to be? 28 times -2. This is a time symbol. This is a negative symbol. All right, where's that bug at? Next. Buggy slides for 3.2 seconds at -8.1 millimeters per second. So this bug is going for 3.2 seconds with a rate of -8.1. Okay, so you're going to need an answer for that. And the last one, I think we're going to let you figure that one out. Jeez, now she's barking at the neighbors. This video is all about Panda Bear. All right, let's move on. What do we got? A tank of water. Let me scoot this up. A tank of water breaks and begins draining at a constant rate. Complete the table. Okay. Well, it looks like it's losing 14 liters every minute, it looks like, because at 0 minutes, obviously it lost 0 liters. So after 1 minute, the change was -14. And it looks like based on this expression, it starts with 770 liters because, yeah, I mean, I guess we could see that pretty clearly here, right? 0 minutes, 0 water lost, nothing started yet, we got 770. And then after 1 minute, when we lose 14, then we got 770 original liters plus 1 minute of losing negative, I shouldn't say losing negative, I should say of -14 change, or losing 14 per minute gets you 756. So what I'll do is I'll do the entire, this row right here so you can see it, and then I'll leave that other row for you to do. So after 2 minutes, the change is going to be 2 times -14, which equals -28. I should have started that more over here. I didn't leave myself good room to do that. Okay, I did the minutes times the change, got me the overall change in that time, which is -28. Now let me write a whole expression that shows that. So I got my original 770, and I'm going to add 2 minutes of change at -14 liters per minute. Okay, original 770, 2 minutes. So you're probably going to have a 5 there on yours. It's always times -14 though, because that's the constant rate. And the answer here is just going to be 770 plus this number here. I lost 28, so plus -28, which is the same as 770 minus 28. Plus negative and minus are the same thing. And so this is what, 742? 742? All right, see if you can sort of just put the pieces together exactly the same for row 5. Okay, wherever I put a 2, you're going to need a 5, basically. Is there a proportional relationship between time, that's this row here, so they want to know about this row, and the amount of water left in the tank, this one here? Explain your reasoning. Right off top, I think it's pretty easy to say the answer to this is no. Hopefully you remember something from proportional relationships, is that like when you draw them on a graph, they have to have 2 things. They got to have a straight line, which this would have if you graphed it, they have a nice straight line, but it's got to start at 0. Wherever your 0 value for one of the quantities is, you got to have 0 for the other. If not, then you have you have something that we call a linear relationship that you're going to work with in 8th grade. These are very, very close to proportional relationships, but because it doesn't have that one thing where 0 minutes isn't 0 liters, we don't consider it proportional for what we're learning in 7th grade math. So you'll learn about these linear relationships in 8th grade. So I would say no, because at 0 minutes, I'm going to let you finish it from there. What's going on at 0 minutes that tells us this is not a proportional relationship? Okay. And lastly, we got our explore. Remember, the rule with the explore is you got to at least try it. If you're doing it online, punch some numbers in. Let me see you try it. If you're doing it in the book, pencil some stuff in. Show me you didn't just leave it blank. Complete the number pyramid puzzles. Each number is the product. That means the answer you get when you multiply numbers of two numbers directly below it. Okay, so like this one here came from multiplying these two numbers. So whatever goes right here must be these two numbers multiplied. -1 times -1 is +1. And so now, because we have these two numbers, we can multiply them together to get what goes here. -2 times 1 is -2. All right, and you just work your way up the whole thing from there. You might have to work your way down, though. It might be like, see, we can't really fill in this one because we don't have both of these. We can't really fill in this one because we don't have both of these. But you can work your way to the top, because now you can fill in this one, and now you can fill in this one, and you'll be able to fill in this one. But from there, you're going to have to think backwards. You're going to have to be like, well, okay, maybe I can figure this one out because I know it has to be this times this equals -1. So let me see if I can figure out what must fill that circle. So work your way up to the top and then work your way back down. All right, see you next time.